So where? First one, second one. OK. Watch, please. So a couple things to remember here, guys. We have y equals negative. Actually, I'm going to change this. Let's change this to a 3. It's OK. It's OK. You're all right. We didn't do it yet. So anyways, we get to y equals a negative 2x squared plus 6x plus 2. OK? So in this case, guys, we notice that we don't have another square number, right? It's not like the bonus over there where it was 4x squared. Negative 2 is not a square number, right? We also know it's 2 is not a square number. So we know definitely this is not a perfect square trinomial. And again, some of you guys weren't paying attention, but x squared plus 3x plus 4, just because the first and last numbers are square numbers doesn't mean it's a perfect square trinomial, right? X squared plus 4x plus 4 is perfect square, but not x squared plus 3x. So you got to still check the outsides first, but then always check the middle, which is 2 times those two numbers. Anyways, here, we're going to do the same thing. We're going to group the first two numbers, because we need to create a perfect square trinomial. Because we don't have one, right? If we had one, we would just factor it and we'd be done. Would you guys agree? Yeah. OK, we don't have one. So we're going to create one. Now again, we can't create one, though, unless this first term is, can we take the square root of it? So what we're going to do is we're going to factor out, which is the same thing as dividing out. Oh, I didn't mean to do that, but I won't do it again. You guys get the, actually, you know what? We'll just count this as the second one, because then I'll give you guys some problems to practice. So I'll try to take this a little bit slower since I'm not going to do another example. OK. Please follow. OK? All right. Is everybody OK with how me factoring this out?
No. Yeah, you factor out 2.
OK. I just factored on there 2. I can now.
B divided by 2 squared. Yeah.
So now I'm going to do b divided by 2. Square it. You got to take the b of inside, right? Because the inside the parentheses is what we're trying to create the perfect square for. So we're going to take negative 3 divided by 2. 2 doesn't divide into negative 3. That's fine. So we square it, which is going to give us a fraction, which I know you guys do not like. But guys, we can go back to grades, fractions. They're numbers too. So again, just like we did over here, we're going to follow the same process. We're going to take y equals negative 2 times x squared minus 3x plus 9/4 plus 2 minus, oh, sorry. OK. So is everybody OK with at least where I've got? Does anybody have any questions here? Because I have some instruction to go on after this.
Finished.
Yes. What? Where? Where did I get 9/4?
No, I know you got 9/4, but why did you put it there?
Because that's what I did over here. Once you get 36, you add it inside the parentheses. This creates a perfect square trinomial. Now, is this a confusing looking problem?
Yeah.
And if I would have given this to you guys on day 1 of pre-calculus and said, you guys got to factor it, you probably would have been like, I have no idea how to factor that, right? It looks really confusing. However, yeah, right? But and that's a good idea because you'll realize this is actually really simple, which I'll explain in just a second. Did you have a question? You're good?
No, I'm good.
All right, answer me this question. Are these two are these two expressions equal? Are they equal in value?
No.
No, they're not equal. Excuse me. Excuse me. They're not an identity, guys, because you have these that applied distributive property, right? That's really a 16. Focus. I only have this last one. So what's important about this, guys, is you really didn't add a 9/4. Or you subtract the 9/4, right? Sorry. Whatever you add, you got to subtract. You really didn't add a 9/4. You added a 9/4 that's being multiplied by negative 2. Just like you add an 8, that 8 is really being multiplied by 2, right? So what that means is, whatever you do on, like if you're going to add and subtract, you really added a 9/4 times negative 2. So this one you need to multiply by a negative 2. OK? Now, I'm not done, Jock. Let's finish. So you guys look at this and you say, I have no idea how to factor this. But all of you did those problems very, very easily, relatively, right? Yeah. So if you guys look at those problems, why did it make it so easy? Because you guys found the pattern. If you have a perfect square trinomial, all the terms is just the square root of the first and last term, and the middle sign is the same, right? Look at x. It's all x's, And then it's all the square roots of the last number. And the middle and the sign is the same as the original sign, right?
Right.
So since I know this is a perfect square trinomial, I created it, right? I made this perfect square trinomial. So I know this can be factored to a binomial squared. So to factor it, all I got to do is take the square root of x squared, which is just x, the square root of my middle term, which is, John, this is not what you need to be doing right now. All I need to do is take the square root of 9/4, which is what? What number multiplied by itself gives me 9/4? -3/2, and that's supposed to be negative, right? OK, now, usually people have trouble with fractions. 2 over 4 gets simplified to 1/2. Haley, this is not what you're supposed to be doing. Negative times negative is a positive. So really, you guys have 2 plus 1/2. OK?
0.5 right
Now, we're not going to be using decimals, but would you guys agree with me? 2 is the same thing as 4 over 2?
Yeah.
OK, so watch. Plus 4/2 plus 1/2. 4/2 plus 1/2 is?
5/2.
5/2. I know why you're lost, and you know why you're lost too. So in this case, we can identify the vertex to 3/2, comma 5/2. OK? Then we know this is negative, so we know the graph opens down. So therefore, this is a absolute max. OK? I'm just telling you guys to put this in context. The other class periods,